Descriptive statistics. There is one slide in this module that refers you to the Peterson and others 2009 article. There are 4 scales or levels of measurement. Nominal is the lowest measure scale. It is categorical. Objects or people are assigned to categories according to some criterion. The categories do not have any quantitative value. Blood type, handedness, type of mental illness, site of hemiplegia are some examples. Dichotomous variables have only 2 categories, such as yes-no, male-female, a binomial variable. Measurement on an ordinal scale requires that categories be rank ordered on the basis of an operationally defined characteristic or property. Many clinical measurements are based on this scale, including sensation, spasticity ratings, manual muscle testing, and functional mobility skill ratings. An interval scale possesses the rank order characteristics of an ordinal scale, but also demonstrates known and equal distances or intervals between the units of measurement. Therefore, relative difference in equivalence within a scale can be determined. What is not supplied by an interval scale is the absolute magnitude of an attribute because interval measures are not related to a true zero. Temperature is an example of an interval scale. Think of how 0 represents a different value on a Celsius scale compared to a Fahrenheit scale. Finally, the highest level of measurement is the ratio scale, which is an interval scale with an absolute 0 point that has empirical rather than arbitrary meaning. Range of motion, height, weight, and force are all examples of ratio scales. Now, notice the acronym vertically on the slide. NOIR, remembered by No Oil in Rivers. It is hopeful that the majority of this module is a review of previous learned content. There are 3 categories of statistics. Descriptive statistics are used to characterize the shape, central tendency, and variability within a set of data, often with the intent to descript a population. Measures of population characteristics are called parameters. A descriptive index computed from sample data is called a statistic. When researchers generalize sample data to populations, they use statistics to estimate population parameters. Inferential statistics involve a decision-making process that allows us to estimate population characteristics from sample data. The success of this process requires that we make certain assumptions about how well the sample represents the larger population. These assumptions are based on 2 important concepts of statistical reasoning: probability and sampling error. Finally, clinically relevant statistics refer to terms like minimal clinically important difference, minimal detectable difference, and minimum significant difference. Today, we will focus on descriptive statistics. A set of scores for a particular variable is called a distribution. Although visual inspection of a distribution allows us to see all the scores, a list could be long and unwieldy, and inadequate for describing a group. It is more effective to summarize the data by presenting them in a frequency distribution. A frequency distribution is a table of rank-ordered scores that shows the number of times each value occurred, or its frequency. Sometimes frequencies are more meaningfully expressed as percentages of the total distribution. We can look at the percentage represented by each score in the distribution, or at the cumulative percentage obtained by adding the percentage value for each score to all percentages that fall below that score. In Table 17.1, you have the raw scores on the left and the frequency distribution on the right. Be aware that there is another way to graph frequency distributions called a stem and leaf plot. A histogram is a bar graph composed of a series of columns, each representing one score or class interval. The graph to the left is a histogram showing the distribution of attitude scores. The frequency of each score is plotted in the y-axis, vertical, and the measured variable, in this case attitude score, is on the x-axis, horizontal. The bars are centered over the scores. A frequency polygraph is a line plot where each point on the line represents frequency or percentage. The frequency polygraph to the right plots the same data set. When graphs of frequency distribution are drawn, the distributions can be characterized by their shape. Some distributions are symmetrical. Each half is a mirror image of the other. The top figure represents a normal distribution. It is symmetrical. In statistical terminology, normal refers to a specific bell-shaped distribution where most of the scores fall in the middle of the scale and progressively fewer fall at the extremes. The bottom figure is considered a skewed distribution. It is asymmetrical in shape. The degree to which the distribution deviates from symmetry is its skewness. The bottom figure is skewed to the left. The right side of the curve is normally distributed. When the curve tails to the left, the distribution is negatively skewed. You would see this type of distribution for an easy exam on which relatively few students achieved a low score. A positively skewed distribution would have a curved tail to the right. It is important for statistical analysis that it is determined if the data set represents a normal distribution or not. When considering statistical analysis, a normal distribution is one of the assumptions that needs to be satisfied with parametric measures. In other words, if your data does not demonstrate a normal distribution, you should use non-parametric measures for your statistical analysis. Although frequency distributions enable us to order data and identify group patterns, they do not provide a practical quantitative summary of a group's characteristics. Numerical indices are needed to describe the typical nature of the data and to reflect different concepts of the center of the distribution. These indices are called measures of central tendency, or averages. The mode is the score that occurs most frequently in a distribution. The mode has only limited application as a measure of central tendency for continuous data, but can be useful in the assessment of categorical variables. The median of a series of observations is that value above which there are as many scores below it. That is, it divides a rank-ordered distribution into two equal halves. When a distribution contains an odd number of scores, such as 4, 5, 6, 7, 8, the middle score, 6, is the median. With an even number of scores, the midpoint between the two middle scores is the median. So, for a series 4, 5, 6, 7, 8, 9, the median lies halfway between 6 and 7. Therefore, the median equals 6.5. Hint: think of a median as a highway divider. It is in the middle. The mean is the sum of a set of scores divided by the number of scores, the average. All three measures of central tendency can be applied to variables on the interval or ratio scales, although the mean is most useful. For data on the nominal scale, only the mode is meaningful. If data are ordinal, both the median and mode can be applied. When considering statistics, only the mean can be subjected to arithmetic manipulations, making it the most reasonable estimate of population characteristics. For this reason, the mean is used more often than the median or mode for statistical analysis of ratio or interval data. Now, let's revisit skewed distributions. With uniform or normal distributions, any of the three averages can be applied with validity. With skewed distributions, however, the mean is limited as a descriptive measure because, unlike the median and mode, it is affected by the quantitative value of every score in the distribution and can be biased by extreme scores. The median, the green vertical line, will typically fall between the mode, the rust-colored vertical line, and the mean, the dark blue vertical line, in a skewed curve, and the mean will be pulled toward the tail. Because of these properties, the choice of which index to report with skewed distributions depends on what facet of information is appropriate to the analysis. It is often reasonable to report all three values to present a complete picture of a distribution's characteristics. The shape and central tendency of a distribution are useful but incomplete descriptors of a sample. Consider the examples on this slide. If we were to describe these two distributions using measures of central tendency only, they would appear identical. However, a careful glance reveals that the scores for Group B are more widely scattered than those for Group A. This difference in variability, or dispersion of scores, is an essential element in data analysis. The description of a sample is not complete unless we can characterize the differences that exist among the scores as well as the central tendency of the data. There are 5 commonly used statistical measures of variability: range, percentiles, variance, standard deviation, and coefficient of variation. You will hear more about some of them. Pause the video at this time to practice answering these questions in reference to the Peterson and others 2009 article. Resume the video when done. The median income in the United States is $44,400. The mean income is $60,500. Why? Pause the video to answer this question. Read through the questions and potential answers. We will work through this problem together. Range is the difference between the highest and lowest values in a distribution. Answer 1 falls outside this range, and you don't have any information about percentages to choose answer 3. And if the SD were smaller than 5, this would represent a more similar population. 2 is the correct answer. These box plots show 4 distributions of scores of functional level based on the gross motor function classification system. The distributions compare the ratio of medium to low activity levels among children who are developing normally and children with cerebral palsy at functional levels 1, 2, and 3. The upper and lower margins of the box indicate the interquartile range, Q3 through Q1, demarcating the 25th and 75th percentiles. The center line sits at the median score, 50th percentile. The outer bars, whiskers, indicate the range of scores at each end of the distribution, with circles indicating outliers beyond 3 standard deviations from the mean. Without getting into the math, understand that standard deviation has to do with the variability or deviation of scores compared to the mean. If you would like to explore the math, go to Chapter 17 of your textbook and read about variance and standard deviation. You are looking at an example of a bar graph showing the mean and error bar indicating 1 standard deviation above and below the mean. The error bars indicate that Group A is less variable than Group B, even though they have the same mean. This is a normal curve depicting proportions. The mean, median, and mode have the same value. The vertical axis of the curve represents the frequency of data. The frequency of scores decreases steadily as scores move in a negative or positive direction away from the mean, with relatively rare observations at the extremes. Statisticians have shown that 34.13% of the area under the normal curve is bounded by the mean, and the score 1 standard deviation above or below the mean. Therefore, 68.26% of the total distribution will have scores within positive -1 standard deviation from the mean. Similarly, positive -2s from the mean will encompass 95.45%, and positive -3s will cover 99.74% of the total area under the curve. At positive -3s, we have accounted for virtually the entire distribution. The type of data measured will impact how it is reported. Consider this chart. This slide is a summary of understanding and interpreting descriptive statistics. To help you utilize descriptive statistics in a more meaningful way, be prepared to solve some simple math problems in lecture this week. The final slide of this PowerPoint presentation contains the answers to the questions you worked on earlier in the PowerPoint presentation.